So, Assalamualaikum warahmatullahi wabarakatuh, and a very good evening, and thanks for making time on Saturday evening before everyone goes out and have a Friday night party, if any of you do that sort of thing. A bit of reminder on PAM online series. We have received approval from LAM on CPD points, and it is only applicable to viewers via Zoom, not on FB Live. So for those who still need to collect CPD points for the year, you need to log in via Zoom. To fulfill the requirement for the CPD points by the Board of Architects Malaysia, we have to have some sort of record on continuous participation by all the audience. So as such, we have devised a system whereby there will be a sign-in code and sign-out code that will pop up on your screen. So if that code pop up, you need to close it by clicking on the code. And at the end of the session, there will be a short questionnaire via a link. You need to access to the link to the questionnaire, respond to the questionnaire in order for you to complete your participation to qualify for CPD point. And a recap on online series. As I have mentioned many times before, the vision of online series is actually to serve as almost like a broadcast house. So that's why we usually fix Thursdays and Saturdays as our fixed time for everyone to log in and share ideas, information, discourses and all that. But today is a special day due to request by our moderator, curators, our special guest architect Wooi. So we accommodate that, but usually we do it on Thursdays and Saturdays, so remember that. So we on behalf of the online series, PAM online series team, I'm proud to inform that we have created about 7 series so far, with over 20 episodes in total over about 4 or 5 months. So that's a big achievement for the team. Congratulations, team. Salam, especially Nani and Nurul at PAM. So the idea is that this series will be a continuous series. Then the episodes will be added on in seasons. So at the end of it, we will compile this series into special, compilation, probably an ebook or something. And some of these series are already available on YouTube, PAM YouTube Media Center, and on PAM app, which is already available and launched, but we are yet to announce it to members. So, so today's session is under Timber Talk series. We have 2 special guests here. Our moderator, curator will introduce the speakers. It's a special topic, timber engineering. I'm very excited to see some of the good examples shared by our speaker today. I just introduced our moderator, curator, the key person to this episode, architect Wooi Kuang from Wooi Architects, a familiar face to Malaysia, not just in construction building industry, but I think he is already a familiar face to Malaysia because he has received various awards, especially on timber building. So he has, to me, he is one of the architect here that has applied timber beyond the traditional and conventional method, and he would like to pursue that further in looking at new ways to use timber efficiently and efficiently and with optimum resources that we have. So without further ado, I'll pass it over to architect Wooi Kuang to take over and take the console. Over to you, Lok. Thank you very much.
Okay, thank you very much. And also thanks PAM for this wonderful PAM online series, especially in the COVID. And then also, of course, Sophie for letting me taking the charge, rightly or wrongly. But anyway, we're going to have some fun today. But first, let me also maybe talk a little bit about the timber, why we have this talk. And today, actually, I'm very, very excited because I speak to the both speaker before today, and why, right? And as I'm also very active in education, I know with practitioner and student, not so much student maybe, practitioner, we know that we have a lot of timber, and then something is a material that we are very nervous about, right? If you use it wrongly, the client is going to give you a problem, how come it's not done? And then generally, the other thing is that in Malaysian context, it's generally used for very small building type, right? So today, we are going to have a speaker, both from Rupna Holzbau, that they're going to show us a new angle of using timber. And they obviously have done it very well because last year, I think the building that I think the main speaker I'm going to introduce later is actually have a very hands-on experience from conception to finish. That is Mactan Cebu Airport. It's a very large scale building. So that perhaps give a practitioner like Malaysia, I mean, I'm sure there will be some engineer might be among the audience, or even the developer, maybe, or even the student, is that we're going to look at timber in a different way. And then timber in the sense that it's a main structure. It's not a cladding to actually support a very large scale building. And they won the, like what I said, World Architecture Festival Award last year on the transport category, if I'm not mistaken, right? So, and then I think I'm very grateful to Anton Wanas, who agreed to share his experience with us. And the other thing with Malaysian, I think, you know, we have a lot of timber, we know it, and then it's the only renewable resource, just like Sophie has mentioned, that is something that we know as architects. And we tend to be quite lazy about it. If somebody do something, oh, must be in Europe somewhere, then they do it, right? But of course, the Mactan Cebu Airport is in Philippines, right? Very close by. And then they are using, well, I'll let Anton talk about that later. And then it's even closer than you think. Actually, it's in Singapore. They are doing some multi-story building. I tried to bribe Anton, but Anton said because it's still in progress, but he won't take bribes. So he's going to share as much as we can. And then I know in my Facebook that bring about this talk, I promised some timber high-rise. We're going to talk about that as well. And Anton have his own angle of looking at this. And I look forward to a discussion later. And later, after the two speakers speak, you're going to have a Q&A, and then you can start typing in your question at the side there in the chat. But first, let me get to Anton Wanas. I'm not going to read out his resume as what his introduction as he put in the, as you can read in the website already. But basically, he's based in Austria. But now basically he's responsible for all the building of the project in Europe and Asia. So he's a hands-on and a big important guy from the company. And the interesting aspect about Rupna Holzbau, they are not the engineering consulting company. They're actually engineering, and then they produce the work as well, the actual structure as well. So the main thing is about blue lamp timber structure. And I will let her talk a bit on that one, but here we have two major, he's now currently involved in two major things. One already completed is Mactan Cebu Airport. The other one I understand is Clark Airport, also in Philippines, and a few multi-story building in Singapore, right? And the second speaker is a glamorous Phyllis Chong, hail from Malaysia, but actually now is a lady of the world. She's like very uncharacteristic of her profession, a chartered quantity surveyor. We tend to think of our quantity surveyor as a very boring person, but she's not. Obviously, you can see there. You know, I'm a bit underdressed just to make two of them look good. You know, but she is actually, her role is a business development manager in Rupna Holzbau, and he's in charge of expanding the glue lamp use in Asia as a sustainable resource. So I think without further ado, I will pass the floor to the main speaker, and yeah, the floor is yours, Anton. I hope I give you a reasonable introduction there.
Thank you for that. But I thought we would start Phyllis first with the introduction of the material itself.
Yeah, I will start first.
Okay. That's fine. Let's let Phyllis start first. It's okay.
I start first because, so let me share the screen. So, okay, first, I would like to thank you, Malaysia Institute of Architects, inviting me to join this timber talk with the professionals in Malaysia and also other professionals from maybe other part of the world. I don't know who is here. So I would like to explain why the timber is the construction material of the first century. And of course, I will briefly introduce our organization and the type of timber engineering product that we have. So look at here, timber, the construction material of the 21st century. You may ask yourself why. So nowadays, the climate is change is a big concern. We live in a time when the climate is a key consideration to our planet. So the effect of the climate change will influence our lifestyle, and for what we are doing, we'll bring an impact to our environment and climate. So it comes to the timber now. So timber is the only renewable construction material on the planet and absorbs carbon dioxide during its growth. So what is not very common and well known is that the use of timber can help to save the climate. So sustainable use of the timber, it can slow down the emission of carbon dioxide in the atmosphere and reduces the greenhouse gas emissions. So the use of the timber helps to save the climate more efficiently is because it's not only renewable, but also every harvest makes the space for a new tree to absorb the carbon dioxide. So, and this is why the use of timber in construction is a very good idea because timber constructions help actively save the climate. So a key fact you can see here is that the 1 meter cube of timber can store 1 ton of carbon dioxide, right? So this is why building with the timber is building for the future generations. So the use of timber not only reduces the environment impact to the planet, it also helps to reduce the consequences of the industrialization of the 20th century. So now we need to build a better environment to the next generations. So the next point I will need to talk about is the source and where the timber is coming from. So here now we go back to the Europe now. So forests cover about 30% of this earthland. So Austria is a small country in the center of Europe. It's one of the countries in Europe that has the highest forest coverage. So in Austria, there's about 50% of the forest area, and that equals to 3.4 billion trees in Austria. So it is always a concern about what happens if you use too much of the timbers for constructions, okay? But in Austria, in Europe, we are quite lucky because we have a sustainable managed forest. So more trees are growing than being cut down for constructions and other uses. So we will not have a shortfall of the timber material and bring harmful impact to the environment. So out of 31 million meter cube of yearly forest growth, there's only 26 million meter cube of timber without having for additional use. So there are a lot of trees for additional use for timber without having any negative impact. So it's important that the timber doesn't come from anywhere. It's not certified. So we Rubner only using certified timber. So we exclusively use this timber from sustainable managed forests, which is certified by this PEFC. It stands for Program for the Endorsement of Forest Certification. So this is in every timber. This one is on our timber. Okay, so we just want to briefly introduce our organization. So we are a family Rubner Group. We are a family-owned business. We have more than 1,500 employees, 27 companies located at 20 locations around the world. So we have 5 divisions. We have timber industry, which is a sawmill, timber engineering, Rubner Hospital. We also have turnkey projects. The other divisions are housing and also door. So only timber engineering divisions is operating internationally. So Rubner Hospital. Hospital means constructing with timber or timber engineering. So we have a number of timber engineering product. We have a chrome laminated timber, scrollum. We have prefabricated roof elements, prefabricated wall elements, cross-laminated timber, CLT, wood glass facades, and we also provide an envelope solutions. So I think maybe a lot of you already know what is Kuang, or maybe not. So Kuang is an engineered wood that comprising multiple layers of finger-jointed lamellas. So it is an ideal material for long-spanning structures and for the strong building structures as well. So it is produced by a high high industrial product that produced by modern computer numerical control machinery. We call CNC machine. Well, you can see it later in the video that we are going to show you. And well, I finished my part. So now let's Mr. Anton Wanas will discuss with you the timber engineering product in detail. Let me start sharing my file.
Okay, so thank you, Phyllis. Let me share my screen, which should be at the moment the same slide what you have seen before, and I will continue. A second. Should be there in a second.
I think this, Anton, maybe your voice is a bit soft. I don't know, is it me or?
It's okay on my side.
Yeah, okay.
On my side too.
Can you see the screen?
Yes.
Okay. Okay, ladies and gentlemen, let me quickly start my part. I'm really happy to be here, and it's my big pleasure and my honor to talk about glulam as a material, and then to tell you a little bit of the story, what brought us here to introduce glulam in this part of the world, and about this journey which brought us to here, starting all with the Mactan Cebu Airport project, which I will talk a little bit more in detail later on. But let's continue first with the glulam itself. So is what Phyllis has told you. First, it starts with the material itself from the forest. And what we then have to make out of it is an industrial product, which we can be sure that it's always at the same quality with the same properties. Because any natural material has always a range of qualities and a range of properties. But with this process, making it from the natural material to lamellas, to a industrialized product, this is the step where we are in a position that we can do engineered structures with it. And the code of compliance, how glulam is manufactured in Europe, which is most of the glulam in the world is coming from Europe, is EN, all following European codes, EN 14080. It's more or less the golden book for manufacturing glulam. The process, if you set up a glulam factory, is there has to be an initial type testing. This is a very long and very painful process with hundreds and hundreds of samples being tested. So to make sure that all the machinery and all the process is in place and in compliance with the code. And as part of the code, there is the factory production control. That means every day, as a daily routine, numerous samples have to be taken and tested. And on top of that, there is a third-party inspection twice a year coming out of the blue without further notice to make sure and checking if your own in-house factory production control is in place. So this is to make sure that we have really a continuous quality on the product. And with that, we have this CE marking. So that means each and every little piece coming out of our factory, and not only out of our factory, of all factories in Europe, manufacturing following this code, each and every piece has to have this sticker on it. It's a small label saying each and every information about the quality, about size, about the properties of this material. So you can be 100% sure what is manufactured following this process does fulfill the requirements what you have up front. So up to now, we have only been talking about the material, but just as important is to have a reliable instrument for the design, because we need to know how to design all these structures. And for the design part, we're also relying on European codes. There is the EN 1995, it's the Eurocode 5. It's the design code to which timber structures have to be designed. Compared to other codes in the world, I can say that this, even the basis design code, Eurocode 5, is one of the most advanced design codes for timber structures in the world. And on top of that, there is also an instrument how to design for fire resistance. So this would be also inside Eurocode 5 is the code for structural fire design. So we have the material, which is tested. We have the design code for the structure and for the fire design. And we have all the certificates. And with these instruments, we can now move on and think about how to make buildings with it. In Europe, that's a long story and not really something new. But to take it into Asia, there are some considerations and a number of questions I'm always being asked. And the main considerations and the main issues what people have here is how to deal with fire, how to deal with the termites, and how to deal with the tropical climate. So let's have a closer look, topic by topic. And first with the fire resistance, as I've said just before, is we have this fire design. We have this Eurocode 5, where a particular chapter, this is 1995-12, is only talking about structural fire design. And the idea behind it is the fire is to achieve the fire resistance by oversizing. Timber is a combustible material, so this is nothing what we can really change. But it's very predictable how it behaves in fire. That means we have a charring rate of generally 0.7 mm per minute. And with this information, we can then design the remaining section of the glulam and make the justification for it. So that means we can design a timber structure for 30, 60, 90, or what we have now, especially in Singapore, in some cases, 120 minutes fire resistance without any additional coating or cladding. It's simply by pure oversizing what we are losing in the case of fire during the charring. So this is the concept behind structural fire design following Eurocode. The next topic itself is the termites. So we also in Europe have some insects, and sometimes we have to do something against that, but termites is a different story. I have learned there are some preventive measures which are more or less given things in Asia. That means chemical ground treatment is more or less done in all of the construction sites, including some measures like termite mesh in the foundations. And what we can do in particular for the timber is, and this is what we doing, chemical glulam surface treatment. That means it's a chemical treatment which is brush applied to the surface of the glulam. I have to say the glulam normally is coated anyway, either with 1 or 2 layers of surface treatment, just to protect it from getting any dirt or any stain into the surface. And before we apply this, we would apply additional layer of anti-termite treatment. And the other thing is, in the way how we construct it, we have to make sure that we make it as difficult as possible for the termites to access the timber. For instance, if we have a structure which is going directly to the ground, we always have to separate it. It's what is shown in this detail here. So never put the timber directly into the ground, which should not be done anyway. So we always have to separate it, that there is at least a distance of 250 or 300 mm until it touches the ground. And the third thing I've always learned, I've also learned from local people here is that there should be a frequent inspection, let's say at least once a year from a professional pest controller to make sure, just in case there's something going on, it's detected early stage. The third topic, which I frequently ask, is how to deal with a tropical climate. Well, climate is always having 2 parts. The one is the temperature and the other is the humidity. Temperature basically is not the issue for the timber. Humidity is to a certain extent. With the combination of temperature and humidity, the timber is taking on a certain amount of moisture, and this leads to a level which is called the equilibrium moisture content. And there is nothing what you can do against it, because this equilibrium moisture content, it's the amount of water the timber will take on under the environment it is exposed to. And this depends one hand to the temperature and to the humidity. And we have put in here in this slide the climate graph of Kuala Lumpur, which tells you about the temperature and the humidity. And I would say the maximum is a temperature over the year about 33 degrees Celsius and a relative humidity of 66%. And there are calculation methods and graphs where you can find out with these 2 figures what would be the equilibrium moisture content. And for these 2 figures, it would be 11.7%. The minimum would be, following this graph, 22 centigrade, about 60% humidity, and that would lead to 10.9%. And for the timber, however, on a long run, whatever is lower than 20% is absolutely no issue at all. And what I can explain you, and I can show you later from our own experience on the Philippines, that the figures there are a little bit stronger than Kuala Lumpur. And following the graphs, we should be somewhere around 17%. And in reality, we are in between 13 and 14%. So the tropical climate itself is not anything which is harmful to the timber at all. However, we have to be careful in the design, because what needs to be sure is that the timber is never exposed directly to the weather and to the rain. But this has nothing to do with the tropical climate. This is a rule of timber engineering and timber design, which we also have to follow in Europe, because if you have the timber exposed to the elements, to the rain, then there are some things what you could do, but on the long run, you always will have a durability issue. As long as you cover it from the top and make sure that it's not directly exposed to the weather, it will be no problem. And there are examples in Europe where we have covered bridges or timber structures. They are 300 and 400 years old. So it's not a matter of aging. It's simply a matter how it is designed and how it is constructed. So with this basis information, it would be now my great pleasure to move on to one of our proudest projects, what we have ever done. And again, as I said before, it was the first project what we have done in Asia. And at the same time, even personally for me, a journey to introduce this type of construction in Asia is the Mactan Cebu airport on the Philippines. The architect was IDA from Hong Kong, Mr. Winston Zhu, and the client was a joint venture from a Megawide, which is a Philippine construction company based in Manila. And on the other hand of the joint venture is the GMR Group from India, is the fourth largest private airport operator in the world. And the joint venture of these two companies did not only construct this terminal, they are also the operators of the airport, because following a private-public partnership model, the Philippine government has handed over the concession to operate this airport to this joint venture for the next 25 years. And I would like to start with a short story. When I have been first in touch with this project, it was almost 5 years ago. It was in the January 2015. We have, as the Rubner Group, exhibited at one of the biggest trade exhibitions in the construction industry. It was the BAU in Munich in Germany. And I was personally there for 2 or 3 days. And the first day I was back home in the office, one of my colleagues called me and said, Anton, somebody was just here to ask us about our involvement for an airport building in the Philippines. And I said, what? The Philippines? Airport? Forget it. Nobody will ever build an airport in the Philippines. Not from European timber, and an airport building in timber in the Philippines, forget it. It will be far too expensive, too complicated, the transportation, all that foreign people, hundreds and hundreds of problems, forget it. We will not do this. Well, what a mistake would that have been? Because now, only 2 years later, the Mactan Cebu International Airport is open, and it's now the second largest airport in the Philippines, serving more than 12 million passengers per year. And from this new terminal building, more than 3 million passengers can depart with 26 airlines to 23 international destinations. And whenever I see these pictures, I'm really excited, because my first attempt was, no, forget it, we will not do it. And in the end, I'm very happy that at one point we have changed our mind. And why did we change our mind? The idea is the concept of the airport itself. What you see here is the first architectural concept, because the idea of the operators was to build something absolutely extraordinary, something what the world has never seen before. The idea was to build the world's friendliest airport, and an airport that feels like a resort, or a resort that has an airport, to make a completely different experience to the traveler when he is either departing or arriving at this airport. And with this idea, they have made a decision about the surface appearance when you enter the building. And from this point on, it was clear that the internal feeling has to show the warmth of a timber surface. And at this point, they had no idea and no clue that it would be possible to build it entirely from timber, because the original design intent was to build it as a steel structure and only clad it with timber. The building itself, this terminal building, has a footprint of roughly 25,000 square meters, and it consists of these wave-shaped roof barrels, which each having a span of 30 meters, and the beams itself separated 13.2 meters. And what you see here now is more or less the whole information what we have got during tender stage. It was a design and build tender, and for a steel structure, the design ideas have been far more advanced. As I said, the original idea was to construct it with steel and only clad it with timber. And then they found out that in Europe there's some technology they could do it completely and with the original material. So during the tender, what you see here is what our tender design was. So we have made big investment to participate in this tender. I was personally also responsible for the tender process from our end, and we have invested, I don't know how many months of work, of design work and engineering work, even upfront. And also these 3D models we have already made during tender stage, not even knowing if we would ever be successful with that. And then, yeah, we submitted our quotation, and then they have invited us for technical discussions. And the original idea what they had is, what you see here is the slab, the concrete slab. On top of the concrete slab, 6 meters high, they wanted to have steel columns, and on top of these steel columns, the idea was with a moment connection to connect these timber arches. Well, this was possible in a way, and we have designed it following this, as it was the request from the beginning, but some problems would have been involved, especially for our client. The one thing was to have this extra trade in between the concrete and the timber of the steel columns. The other was the installation process would have been much more complicated and more time consuming. And one of the bigger concerns also how to achieve the accuracy of this steel work, because this type of structure would not have allowed any intolerance. So at one point they have then asked us, would there be another option? And our suggestion was then to bring the arch all the way down to the slab level and skip the steel columns. That was possible from our end, but also some extra challenges have been involved with that. One of these challenges was that there was a request up to 6 meters from finished floor level to achieve a fire resistance of 120 minutes. And the other challenge was that it was not allowed for us, for architectural reasons, to introduce any diagonal bracings from this 6 meter level to the ground. And on top of these two issues, of course, the size of the arches has been a little bit bigger. So all the transportation issues, they have got a little bit more complicated as they have been anyway. And what you see here on this slide is what I explained before. This is the except of our structural model. We have a very traditional diagonal bracing, also made from glulam bars, horizontal members between the main beams. But all this is stopping at this level, 6 meters above the last floor level, because for architectural reasons, they didn't want to have any bracing. So they wanted to have it completely clear from any structural element below this 6 meter level. And the problem was one of the governing load cases has been the seismic design. That means the horizontal effort in the seismic case had to be swallowed completely from this leg of the arch, because up it was stabilized from the horizontal members and the diagonal members, but going from these last horizontal members to the floor, no stabilization at all. So, and this was really one of our biggest headaches design-wise. And the solution to this was this design of the beams. So we have one beam in the middle, which is normally 280 mm thick. And then we have made multiple layers, all in all 5 layers of glulam beams glued together to this massive bottom section of this arch, which had a maximum width of 860 mm. And when I saw the first ideas from our engineers, they said, guys, you are crazy. It will be far too big. It will look ugly. And in the end, I have to say, it looks just fine. This is what you see here. 5 layers of glulam block glued together. And with this, we could achieve the 120 minutes fire resistance, because there's enough material, even in the jarring case. You're losing roughly 80 mm, 85 mm either side in this 120-minute fire case, and also enough strong material to absorb the horizontal impact in the seismic design. And yes, this was in the end what they have accepted. So we could start with the production. What you see here is how a glulam beam, how a curved glulam beam is made. These blue columns in the background are set up automatically in the way how the beam is shaped, and then always a pair of beams consisting of these single lamellas is pressed against this form created with these columns. And once the glue is hard, it cannot move anymore. That means the beam is keeping its shape, and this takes normally for a beam this size somewhere in between 3 and 4 hours, and then it can be released from the press. It is planed so that all 4 sides are really nice surfaced, and then it is cut to size, all CNC machined. Nothing is done by hand. The cuts and slits, slots and drills are all done from a huge CNC machine. And what we have here is then the process of block glued, so that several layers of glulam and then glued together to achieve the right thickness. This has to be done in 2 steps. So the first steps is gluing together only 3 layers. Then we had to install this massive bottom hinge connector, which is connected to the glulam with not less than 120 screws either side. And once this is installed, the last layer on both sides is again a number of 2 glulam pieces, each 100 mm thick, is attached to the beam. And this is the finished glulam beam itself. Next step then is to wrap it carefully as it has to go on a long journey. And this long journey was a headache on itself, I have to say. But we had to invest really a lot of time to get a good solution. But in the end, we found a way how to do it. Our factory is roughly 30 kilometers away from Austria's biggest river, which is the Danube River. And there's a small river port. So we put all the glue lumps in a river barge. From this river barge, from Krems port, it went upstream the Danube River, and there's the Rhine-Main-Danube channel. So it's a inter-European waterway connecting countries like Austria with the sea at Antwerp, Belgium. And here we had to shift everything into a seagoing vessel, which then went all the way to the Philippines. And from our factory to site, it took roughly just under 3 months. In the end, it worked out really well, but I have to say the last 10 kilometers from Cebu port to the airport itself by truck on the Philippines is that what cost me 95% of the trouble. So once again, this is the river barge leaving Krems port, and this is how we have discharged it at Mactan Cebu port. Between these two images, there have been almost 3 months. When we have received the first shipload, I have to say we have split it up in 3 batches, so 3 shiploads. I was personally attending a full night at the harbor to make sure that we get really the first beams on site in the right time. And this was a really very exciting moment for me to have the first beams arriving Philippines. And the next morning, we arrived on site with extendable trailers. And I was really very, very happy when we had all the material here. But we never can forget, this was a very long story for us to get all the material designed, fabricated, and then arriving on site. But this was in the end only the beginning, but this is where the whole work started for us on site. I was very happy that the design of our packaging and how we wrapped it did really survive the whole journey and the whole process without any damage. One of the first things I have done is to check the moisture content, and we have been at 14.6, which is in the range and is absolutely fine, because this is less what we have identified from the climate charts. And sorry. And yeah, once we have unwrapped everything, we have our own installation team there. A number of 8 guys coming from Europe installing the complete airport with local equipment of truck cranes and cherry pickers. The idea how to install it started with put in the bottom hinge connectors first with these massive bolts, and always 2 beams, creating a pair, and minimum 2 cranes. Sometimes we had to use 3 cranes. We installed 1 beam after another. And this was something that we have designed also step by step, very carefully. And yeah, it worked really well. At the beginning, it was a little bit slow. And then after a few days, nobody could believe, especially not the people from our client, how quick the installation really was. So with only these few people, maximum we had 8 people on site, we installed sometimes 2 or 3 of these grid lines every day. And one of the key elements of the speed of our progress there was the design of the connections. And we have purposely designed the connections in a very traditional way. You see these steel connectors. All these steel connectors are connected to the glue lumps with fully threaded screws on site, because otherwise, if we would have done that in the factory, that would have irritated the transportation too much. So it was easier to send this separately in a container and then install it shortly before erecting the beams. And the connection of these diagonal members and bracings and these short tie bars was only one small bolt in this steel-to-steel connection. And this went really perfect and was very, very quick operation. So here you see the main departing hall on the departure level. And this was after the second of 3 batches of glue lump has been installed. So from the very beginning to this, it took us roughly 3.5, 4 months. Yeah, and here you can see on the left side that already the roofing company has started to install the roof covering. And this is almost completed from the other side where the entrance is. What I would like to explain here is what you can see is that the glue lump itself on the end beams is outside the facade. We have been talking about this before, about the exposure of glue lump, and these glue lump beams are definitely exposed to the outside environment, to the air, so to the temperature and to the humidity. But this is not an issue and not a problem as long as it's covered. And they have quite a good coverage here, but the coverage is not so good on this bottom end here. And what you see, even we did not need it from the structural point of view, we have also put on one extra layer of glue lump. And this is more or less for these beams only a sacrificial layer, which could be replaced maybe after 20 or 25 years. What is not completely finished on this picture yet, as it's done during construction, is that these gutter beams have then later been cladded with metal sheets. Yeah, and we made good progress, and after a couple months, this is what you could see from the inside. These very small strips of glue lump timber, what you see here, they are at the separation of 620 mm, sorry, 620 mm, always one long and one short of these decorative glue lump timber strips. It was a very, very long discussion with the architects until we could agree on the final setup. But if you have a look at this now, I can say it really paid off because it looks definitely great. And it swallows a lot of the size of the glue lump beams itself. And it also makes some room and some space for all the sprinkler system and all the lights and all the wiring, what is all hidden behind these strips. So if you go inside this building, you cannot really identify that there is a full sprinkler system. You only, if you have a closer look here, you see a few of the sprinkler heads here and there, but overall, it's not really irritating. And one other thing you can see here, it really paid off that we had to avoid all diagonal bracings below the 6 meter level, because it looks really so much better without having some irritation there. Yeah, another few months later, the fit out works have already been in full progress. This was taken somewhere, I think in May 2018. I have to say I had the honor to go back in May 2018 because we have been already in discussion with the same client about the next project. And this was by pure occasion at the same time when the opening ceremony was for this airport. Yeah, you see some of the areas are still under construction. Some of the areas are already finished to an extent where you would really love to be there and enter a plane from this terminal building. This is almost finished. You see they have put up the seats already for the opening ceremony, which then took place in the last days of June 2018, even with Mr. President of the Philippines attending the opening ceremony. And you see here also the impressive light system, what they have installed here, all hidden behind these decorative timber strips. Yes, and this was the story from the Mactan Cebu airport, which first, when I have been approached from my colleague, I said, forget it, that will never be done. Nobody will ever build it. And then a few years later, in the night from the 1st July 2018, the first airplane docked onto a passenger gate of this new terminal building. And it was really a big success for us, and the client was very, very happy with us, very satisfied. And this brought us into the position to talk about the next project, also on the Philippines, which is Clark International Airport. Clark Airport is about 80 kilometers north of Manila, and the Manila airport is quite congested, and there is not much room there for any extension or so. So they decided to extend the Clark Airport to release a little bit the pressure on the Manila airport. The idea was also similar, to have a glulam structure. And this is what you see here. The main difference is that we don't have the same height of these beams because it's different. So we have 3 different types of beams. And the major difference at all is that the glulam structure does not go all the way to the slab level, because they decided to have 6-meter concrete columns and start with the glulam from these concrete columns on. But other than that, the idea is still quite similar. We have a similar connection strategy for the secondary beams and also for the bracings. And also the installation idea is all very similar. However, the size of the building is completely different, as the footprint of this one is 47,000 square meters, so almost the double than Cebu. And what you see in the background is the mount, if I'm not wrong, Mount Arayat, and this is one of these typical Filipino volcanic mountains, and the architectural concept was to display the shape of the ridge, of the mountain ridge, in the different levels of this roof. This was the design idea behind it. Inside, they have also changed the material of the soffit. So this is a white metal liner as a soffit, and with the white metal liner soffit and the concrete columns, you see that it's a little bit of a different appearance. It looks a little bit more industrial, but it's not less impressive, as the height is more than 20 meters in this central middle bay. It's a different image. Yes, so let's move on now from the Philippines to, I would say, the other also very important country in Asia. Might be interesting for you. It's your neighbor country. It's in Singapore. Singapore has started, I would say, 3 years ago to think about glulam. And in the meantime, we have done minimum 15 different jobs in Singapore. In Singapore, we are working with a local partner, as the job size there is significantly smaller as these two big projects what we have done on the Philippines. That means we need somebody to take care of the installation and to keep in touch with the local authorities, to have the submissions with the building and construction authority and things like that. So one of the most impressive things what we have built so far is this sport building. Unfortunately, I only have images during the construction process, as it's still due to the COVID-19 situation, there's some delay and it's still not completely finished and handed over. But the important thing I would like to show you is what you can see here is a sport building with 38-meter free span. And these beams are all made of glulam, have a total length from outside to outside from just under 39 meters. And we have shipped them to Singapore with full length and also this double arrangement, as they are always a pair of two beams together, which we have already arranged in the factory and shipped them together and brought them to site together. And these columns, what you see here, the spacing of 8.5 meter roughly, are also an arrangement of 3 glulam members, and the central member is coming up here like a mortise and tenon connection. So this works with only very, very few steel connectors. The only massive steel connectors what we had, what you can see on the next image a little bit, is at the bottom of these columns. The columns are with a rigid, with a moment connection with the steel. And then we only have very, very small steel connectors. So far I can say these are the longest spanning timber beams in Singapore, and I think in all Asia at the moment. So this is the highlight in beams length or maximum free span, what we have done so far in Singapore. From the factory perspective, I can say we are able to manufacture up to 50 meters in one piece. And one of the buildings which are now in progress, and Mr. Architect Locke asked me to tell a little bit more about this in particular, but I have to be careful as at the moment this is still in progress. We have just started to manufacture the first members for this project, let's say 2 or 3 weeks ago. So nothing has arrived on site yet. And even to the COVID-19 situation, there is some delay in the installation and in the beginning of the installation process. The building is called BCA Academy Singapore. BCA is the Building and Construction Authority in Singapore, and they operate their own academy. This is a multifunctional building with a 7-story timber block, and then right adjacent to it, a 16-story office building. And this should be the new headquarters and also the new academy for educational reasons. And what they have in mind is absolutely to showcase the state of the art of construction, of sustainable construction, and also how the process is done. Of course, it's working with full beam. And the only thing I can share with you at the moment is 2 slides showing you a little bit of the structure itself, because these are designed and done by ourselves. So I'm not touching anybody by sharing this with you. It's a 7-story building with a grid shell of 8.4 by 8.4 meters. And the important thing is what you can see on the top level, there is a multifunctional room, like for events. And this is also covered with beams. They are also, I think, 36 meters in span. First, they had in mind also to build the lift shafts and the escape stairs in timber. That was the original intent from the very beginning. And even I've told them it might be not a good idea. They said, no, it has to be, it has to be. But later on, the fire and safety authorities said, no, it has to be changed to steel. So what you see here in gray is all steelwork, and the rest, all the columns and all the beams are from glulam, and the floors are made from CLT, from cross-laminated timber. Here you can see the other side of the building, so it looks quite similar from both ways. What is maybe also a little bit the speciality on it, we have developed our own connector for this beam and column connection, because the challenge is how to connect these two things together with a steel connector, which can swallow 2 hours of fire design, because the required fire design for this building is 2 hours. And on the other hand, we need to minimize the on-site operations. So best would be to do it already in the factory, so that you don't have to play around on site, and also to have the required accuracy for this. And for this, we have developed, as I said, our own steel connector. I can unfortunately not share too many details of it at the moment, but maybe we can have a similar session maybe next year or the year after, once the building is complete and once I have official the clearance from our client, the BCA, then I can make you a separate show and a separate presentation of this building only. But please understand, it's a little bit too early at this point now. But it will be one of the most important timber buildings in Singapore in the future. Yeah, one of the other things I would like to show you is another use case, quite a typical use case for a train station. This is a train station, and they call it operation center for a small local train company. You can see this architectural feature with this diagonal beam arrangement. And a very nice looking timber soffit. This is made from 3-ply timber boards with a pattern of small holes. This is for sound absorption. And what they have also here is a maintenance center for the trains, where they do all the maintenance work. So it's not only train station, also operational center. So you see also for a train station, that would be quite a typical use case, what can be easily achieved. I think we are now at the next, and this should be the final one, example. It's back in Austria, in the south of Vienna, around 2 hours driving from Vienna is the city of Graz. We have done a sports center there, and what you see here are beams with a full length of 50 meters. So the maximum length that we can produce is covering this sport building. And with these secondary members between the main beams, you see this quite square pattern in the ceiling, what they have also used for the illumination installation elements. And some secondary part of this sport building is a shorter sport hall. So you see this could be any type of sport building, any type of sport hall. So I think this is the end now. the end of my story, which started with a project in Asia where I have never believed that this would ever happen. But sometimes you have to learn the lesson. And I can say I've learned the lesson, and I'm very happy that we can work in Asia now. And yeah, thank you for listening. I think I can now pass on again to Phyllis and ask her to share with you the short video, what we have promised. Thank you.
Yes, Anton, thank you. So I'm going to show a video, like 3 minutes video. So I'm going to share my screen. Okay, so I think there's one more here. Okay, so now we pass on to Mr. Lo.
Yes. First, Anton, thanks for demystify a lot of things that we see. I love the way you describe. I think are you on? Your audio is off. No. Yeah, no, it's okay. I hear you now. I think the whole process I really appreciate. No wonder you say it's your baby. Yeah, I totally understand it. As a practicing architect, I know everyone sees the end building, but they didn't know the hard work. The most I think exciting bit was the idea of transportation. I was wondering, are you going to fly all those things over? It's quite, you can't fit in the plane, you know. Then you are using the boat. So the ship, you know, So I think it's a tremendous effort. But having said that, there are a few question, but I'm going to give priority to because I started this from Facebook, so I did ask those that interested that what are the questions that they would want to ask. So I will just briefly go through that, but I will not. I think some you already preempting what they want to ask, like humidity and all that. But one is actually from Jacqueline Tan. I think definitely she's working in Singapore or something like that. Is it about MET, mass engineering timber? Is there such a term? And then the maintenance, like what are the measures they should to take note? But you did mention about the fact that you have to inspect it regularly. But apart from that, any other measure that important to take note to maintain the MET?
Yeah. So first, the term MET means mass engineered timber. And I think this, I'm not sure where this MET term was created, but I think it was created somewhere in Singapore, because Singapore is always talking about MET, and mass engineered timber is the overall term for glulam and CLT. So all what is massive timber products. Talking about the maintenance, I can say that timber as a material itself does not need any maintenance.
Right.
Timber does not need maintenance. What is recommended is to have inspection, to have frequent inspection about what is the condition, because the timber itself will not undergo any aging process, but it could be the case if you have, for instance, a leaking roof or a leaking facade and water coming in and water dripping on a timber structure over years, then that could cause damage. And with an inspection, maybe a yearly inspection, you could identify such kind of situations at an early stage. Once it's identified early stage, it will not cause any problem.
Right.
Or very low problem.
Yeah. I think that there's another one by Suzanne, similar questioning about the treatment and all that. But I'm just wondering, like in our humid climate, mushroom grow very readily, apart from what you call when it's shaded, too shaded area, the mushroom would grow. And also whether the issue of delamination, you mentioned that as long as the humidity is below 20, moisture content, sorry, then it is okay.
Yeah.
So would you, the issue of delamination and also like mushroom and other damage?
That is not an issue with the delamination. The issue about the threshold of 20% of equilibrium moisture content is more related to the timber itself. Because if you have if you are under 20%, it's completely unlikely that you will have any timber decay from fungicide. If you have on a long term, maybe 25 or more % equilibrium moisture content, the risk is very high that you have a fungicide infection of the timber and then timber decay from that.
I see. And I think you did also mention that, you know, you have to brush certain chemical to give it additional protection. Like in Malaysia, we have a problem. Like for example, our timber industry, it still has some timber, softer wood, they need treatment. So they use a copper chrome arsenic, which is banned in probably Europe. So what sort of chemical or the type of chemical that is allowed that you're talking about in Europe in your application?
Yeah, there are different types. So this treatment, if I understand correctly, what you're talking about is that high pressure treatment of the lamella. But this is something what would not work for our lamellas, because once it's treated, the lamellas, you cannot bond them together anymore.
Oh, okay. So there was one question about what species of timber that you are using.
The species we use is always softwood, so no hardwood. And majority and all in the projects what you have seen would be spruce.
Spruce, okay.
Spruce. We also can use larch, which is a type of redwood. It's a little bit more durable and a little bit harder. It has a light, it's a type of redwood, a little bit more red appearance like a pine. And we also could use pine, but pine is only available in very low grades, very low strengthness class. So for big structures, we don't use pine. So spruce or larch.
I see, I see. And the other thing now is shift. I think we are too technical. Maybe the other thing that I'd like to find out, how do you actually talk maybe a little bit more about how do you collaborate with the architects in a way that, you know, how it came about. Like, for example, it seems that you are just exhibit your product and then the client directly come to you for quotation or something like that. Maybe you can tell us a bit more about your collaboration to get the final form and the manufacturing aspect.
Yeah. So for all the samples, all the examples, what we have shown in the presentation, maybe except with the train station, there was in Austria a different story as this was a public tender, but all the other ones are more or less in a way design and build jobs. That means we always like to be involved in a quite early stage to have a certain freedom to have our input also design-wise, because timber engineering is a very individual thing, and you need to put in a lot of sometimes tricky engineering effort, and this is very often related to the machinery. So we need to make sure that all the details what we're developing, especially what we have shown at the Mactan Cebu airport with 5 layers of glulam and these very thick steel connectors, that all needs to be in accordance with the machining capacity. So we cannot design some details and then the CNC machine is not able to do this. So that would not help. So you have to always see to have that a holistic approach is always the key for a timber structure, especially for a structure like that, because first is the overall engineering idea has to be a good one. Then in one part of my head, I have to think about the transport solution, how we transport it, and how much can we do in the factory, because we always try to do as much as possible in the factory, because factory work is always higher quality. Always you are in a controlled environment. I have all the tools, all the equipment. You can work with a far better accuracy and far better quality in a factory as you would be able to do on site. But sometimes with some steel connectors, often is not really possible. So if we have to design a connector which has to be installed on site, I need to make sure it's easy going and with simple tools and not too complicated, because people on site have limited equipment and limited options to do. And the next I have to think about how to install it. How is the installation process? So there are a number of things that have to be thought about at the same time.
I see.
And therefore, we really like to be involved in early stage.
But what I'm trying to say is
already at the concept stage, and we are ready to assist in early stage, in concept stage, because sometimes if the concept is not the right one, it's very difficult to make it right later on.
I see, yeah. I think that makes sense. I think what I like to find out more is that how often do you talk to the architects in the process? Or you're pretty much, because he would have his own consultant, and then you would take from the concept and then you start producing. And definitely, like what you just said, certain things are quite tricky. Whatever they want might not be exact the way they want it. And then you have to think more, because you have to manufacture, transport, and all those things involved.
Well, this is the old story that we have on the one end architects, on the other hand engineering consultant or some checking engineers, and we have to do something in between and make sure to satisfy both. But for the example of Mactan Cebu Airport, it was clear what the design idea was and what the concept of the design was. And it was also clear what the structural requirements are. And with this information, we created our own tender design.
Yes.
And this is what we presented to the architects. And of course, there have been some areas where the architect has been happy with us. There have been some areas where we had to go through some discussions.
Yeah, I can see that the speed of it is fantastic. I thought you definitely a very close way of working. Because within 2 years, 25,000 meter is quite a feat to put up so regularly, you know. But we have only about 7 minutes left. I really have to ask you this question because this is a question I throw it to in the Facebook that if I organize a webinar on what you call timber high-rise, would they be interested? And a lot of them say they are. So like the pre-discussion that I had with you, you have a very, very good and specific thought about the issue. So would you like to share the thoughts?
Yeah, of course. So the timber high-rise, of course, everybody is excited to timber and everybody wants to bring timber in the cities and timber high-rise buildings. What we can recognize now is that almost every city in the world is taking part in the race and in the competition having the tallest timber building in the world. And of course, this is very, very important. It's absolutely important because it's a driver for technology, for new developments. But most of these high-rise timber buildings are always one-off. And some of these so-called timber buildings are in fact hybrid buildings. So this combination of steel and timber and concrete. And what we see is that a very good use case is in the way of mid-rise buildings. Let's say somewhere in between 3 and 7 stories. This is where you can really bring the material properties best to work.
Right.
Because a 80 meter or 35-story timber building, be sure it will never be a pure timber building.
Right. Why is that?
Because
of the mechanical strength of timber?
For mechanical properties of the timber are also as they are. Yeah. And at one point you would need to have some collaboration with other materials. Yeah. This is so honest we have to be. Is what we have. And the best is, and this is one very old traditional and I would say golden rules of designing with timber is to make sure to bring the material properties to work at its best. And then the design will be good and it will be good looking, it will be economic. If you try to design against the material properties or beyond that, it will always be a challenge. Sometimes a challenge is a good thing, but we will reach our limits.
Yeah, I get what you're saying. But just quickly, I have to ask you a typical Malaysian question. How much it costs? Your Cebu, we just talk about Cebu or Singapore one, you know, per square feet or whatever, you know?
There are so many answers. I can give you a typical European answer.
Okay.
Or answer on that. That would be, let's not talk about cost.
That is a very Malaysian answer as well. I mean, okay. But just talk about a Cebu app. What do you call the Mactan Cebu Airport? That's about 25,000 square meter. How much is the budget that you ended up with? I suppose it's no longer a secret.
What I can tell you, I cannot tell you any figures, but what I can tell you, of course, the client first, there have been many people in the client audience, and some of them have not been convinced to do it. Some of them wanted to do it in the traditional way, a steel structure and only put some timber cladding on. And in the end, the problem was to convince these people what would the cost be if they compare it like for like. So the one is the steel structure. Of course, steel structure, you need so many tons per square meter, and the ton of steel structure is very, very low, absolutely very low. But
Right.
you have to consider how long it takes.
Yeah.
And how
Okay,
long
I think the speed,
it takes,
yeah.
how many
Okay.
years later you can
You are being invasive, but you are being evasive, not answering me the cost, but I understand.
Sorry for that, Mr. Locke. So sorry for that.
Wait until
But-
we have the
but-
real project, then you can quote for us.
What
Yeah.
I would like to say as a last statement,
Yeah.
we had a visit, an official delegation from the Singapore PCA, so the Building and Construction Authority from Singapore, came to Mactan Cebu airport site whilst it was in installation. So
Yeah.
during the installation process, they came to visit me there, 30 people from the Singapore timber industry. And the project director for my client told them the decision to go from the steel and the cladding to the original timber structure, what we have made, did save their project because it saved them 1.5 years of construction time.
Yeah. Yeah.
And
No,
of
I
course,
accept
ask
that.
the
I think
question, how much was the extra over you had to pay for that?
now I learned something new, how to do business.
They
I'll
say-
follow the European way.
They said, they said it was not really worth it to mention.
Yeah. Yeah, sure. I think we are running short of time a little bit, but I apologize if I cannot go through all the questions, but I think pretty much like weathering, I think you already answered very well. That you just put additional layer as a sacrificial layer when it's exposed to the external weather, like the Cebu Mactan Airport. If I have more time, I will ask you more about Singapore's project because I know I did some background research. I think the Philippine one, they can easily adopt the US standard or something like that. But Singapore, it seems that you're running a bit more against wall a bit because they want you to use steel on certain part and things like that. Definitely, they have a more strict or different set of rules.
You know, Singapore was using also the Euro code as a design code, and Singapore was using for years the United Kingdom, so the UK national annex to the Euro code. And now, since 2 years or 3 years, they have their own Singapore national annex for Euro code. So they have their own Singapore design code. Between us, it's a pure copy of the UK code, but they have their own code.
Oh, okay, that's good.
But
Okay,
you
before
wanna
we
hear-
end,
you
I
know-
just want to tell you, you got a problem here. You're telling me Singaporean food is very good. I think in the pre-discussion, Singaporean is very good copy of Malaysian food. So next time when you come to Malaysia, we will show you the real good food, right?
Not
You know,
sure
I have
is there any Singaporean here though.
No, I don't mind. I got a lot of good Singaporean friends. They can take some jokes. Yeah. So okay, I think with that, I'll probably pass back to Sophie, our main host. And Sophie, thanks for everything. The introduction and all the effort you put in. I think people can see that it's a simple webinar. We went through a very fast footwork. And then again, I thank Anton and Phyllis. Good to see both of you. So apparently, I think Anton haven't got enough problem because he still got full set of hair. So Anton, I hope they will see you one day in Malaysia. And so is Phyllis. One day you'll come home, right?
Definitely, I will go to Malaysia one day with Anton.
Okay, good.
Because due to the COVID-19, we are not able to go to Malaysia to see some of the consultants.
Sure. After this, we become old friends. Now I pass back to Sophie.
Thanks everyone. It's a very interesting presentation and discussion. Of course, there are a lot more questions here, so I'm just wondering if you're okay with it. I shall forward some of the questions through our WhatsApp group, or maybe if Anton is too busy to respond, maybe Phyllis can help out to do that.
Yes,
I have a few questions to ask, like, you know, the percentage of transportation cost against the overall material cost, but
Sophie, it's not talking cost. European way, they don't talk cost.
No, you cannot talk cost on overall, but you can talk cost about relative a component of it. As long as we cannot figure out the total cost, is okay. We can do that in our group discussion, or perhaps depends on Architect Luke's willingness. We probably do another episode on this to talk about more detailed discussion on this, especially in comparison to what's available in Malaysia. You know, glue lamp in Malaysia, is there any species that would be possible or perform similar to the one in Austria or German? That's another question that would be interesting topic. But I won't take any more of everybody's time. So I shall pass this on to Salam. But before that, thank you everyone for joining. It's good to see that 245 sustain the interest in listening to the three of you. And thank you, speakers, and Luke especially for willing.
Thank you.
Thank you for doing this.
It's a pleasure. I have a lot of fun and learn a lot.
Okay.
Yeah.
And we can do it again anytime if you want. So we are really happy to do another session if there is the request for.
Singapore one, Anton, when it's done.
Yeah, we hope the next time will be face-to-face one.
Yes.
Oh, yeah. Oh, that one is pretty evasive answer, because you don't know when it's going to happen.
Yeah.
You're becoming European very quick.
Yeah.
Okay, then thank you. Let's end this. Some people.
By the way, can we have a group photo?
Yeah,
sure. Excellent. Good idea.
Okay, ready guys? Okay, 1, 2, 3. Okay, wait. Okay, another shot. Okay, another shot. 1, 2.
Freestyle.
1, 2, 3. Freestyle. Yes, all right. Thank you.
Anton needs to be educated. Anton don't know what freestyle is. He's just smart.
I will look like emoticon because my shirt.
No, you need to come to Malaysia, Anton. You need to relax. You're in Singapore for too long. You know?
Okay, Salam, over to you. I think people's waiting for the link.
Yeah.
Yeah.
Bye.
Bye.
Bye-bye.
Thank you again.